Hi, I'm Curt Frye. In this video, I would like to show you how to handle a traveling salesman problem where two drivers have an unequal number of stops. In this case, it'll be two drivers with 15 stops, so one will do 8 and one will do 7. The sample file I'm using is tsp_unequal, and if you'd like to follow along, you can download it using the link that I provide in the video description below. Over on the left, in columns A, B, and C, I have a list of stations and their X and Y coordinates on a map. The drivers will visit 1 through 15, and they will start at 16. So if I scroll down, you can see the route maps over on the right, and then I currently have 1 through 15 highlighted in yellow, and then 16 here in cell C29. And my goal is to create a model based on this setup. The problem, of course, is that I can't, and I will get an error when I try to add constraints to the model, and I will show you how to work around that. One other thing, the map itself is created using the X and Y coordinates here, and each column is a data series. So we have the X values and the Y values. So let's go back up and go with the solution as it's currently presented. So I'll go to the Data tab of the ribbon, click Solver, and the objective cell, so I'll click in that box, is E33. I'll click that. We want to minimize the value, and we'll try to do that by changing the variable cells that are in yellow. So B22 through C28, then hold down Control and click B29, then click Add. And our first constraint will be that the cells I selected, and those will be B22 to C28 plus B29, will have to be less than or equal to 15. And I'll click Add. But I get an error. It says the cell reference box is empty or the contents are not valid. And that means that the way I tried to select the cells won't work. And also looking ahead, because I need each of the cells in that range to be different, I can't have B29 with its own criteria. So instead, I'll click OK to get out, click Cancel here, close the dialog box, and add a virtual station that duplicates station number 16, which is the starting point. And that will allow me to have cell C29 be a changing station, and you'll see how that works in a moment. I'll start with my modifications, and there will be quite a few, by selecting cells A17 through C17, then drag the fill handle down to copy the values. The position can stay the same, but I want the station number to be 17. Now I need to update the distance matrix. So I currently have 1 through 16. I'll select the 15 to 16 in column F and drag down, and I'll do the same thing up in row 1. So I have 17s there as labels. And now I need to update the lookup, because we are no longer looking as far down as C17, we're going down to C18. So I need to change that in the 4 places that we have in our VLOOKUP formula. And I covered how this was created in a separate movie earlier in this playlist, if you're wondering exactly what's going on. So there we go. We have all of our C17s updated to C18. So I'll press Enter, and I'll click cell G2 and drag the fill handle down until I cover row 18. So I have 21, 40, 17, and when I drag down and release the left mouse button, I see that none of the values change, and that's good. That means that the previous calculations are repeated and no new errors were introduced. Then, with all the cells still selected, I'll drag the fill handle to the right until it covers column W, and there are all of our calculations. You'll see that 16 and 17 have all the same calculations, and that's good because they are the same spot. And that also gives us these 4 zeros at the bottom right, because going from 16 to 17, 17 to 16, 16 to itself, and 17 to itself all cover a distance of 0. So hopefully what will happen when we create our solution is that we will have one of the drivers go from 16 to 17, which is a distance of 0, which has the effect of giving 8 stops to one driver and 7 to the other. So we'll start both drivers at the same location, so 17 and 17, and enter, and then we'll have them end at 17 as well. And we do it at 17 so we can have 16 as a changing cell. And I'll click cell C29, go up to home, and fill it with yellow. It's not required, but I like to do it to mark the cells that are changing. Now we need to update our distance calculations, our distance lookups rather. So currently we're looking from G2 through V17, which is the old distance matrix. We have extended it to W18, so I will update the formula, and that would be D delta 22. So it's going to W $18. Yep, so that covers the distance matrix, and we'll do the same thing. So that'll be W $18. And again, the dollar signs make sure that the references are absolute and do not change when copied. Enter. Then I'll select D22 and E22, drag the fill handle, and drag it down until it covers row 30. There we go. And I see the distance from 16 to 17 for driver 2, or route 2, is 0. So that's good. We have everything else, and we do need to update our lookups here at the bottom. So we're, instead of going from A2 to C17, remember we need to go to C18 because we added a new station. So that'll be C18, and I'm going to do the same thing for the other cells. So I won't give a lot of commentary. I'm just repeating the same thing 4 times. Enter. And then I will select cells A37 through D37 and drag down. So there I have 9 stops. 1, 2, 3, 4, 5, 6, 7, 8, 9. Yep, that's good. So I have 16 total, 8 each. Oh, actually, I do need to repeat the last one. So I'll drag down. There we go. That will close the loops. So rather than having a gap between the first and last point on a particular route, they will be closed. So there we go. And now we can go back to Solver and create our model. Data tab, Solver. E33 and minimum are still the same, but we are changing the variable cells from B22 through C29, a nice neat rectangle. Expand the dialog. We're going to use the evolutionary engine, and for options on evolutionary, make sure that we have require bounds on variables checked. Click OK, and then we can add our constraints. They're the same as before, except now we are always working on the range B22 to C29. Those have to be less than or equal to 16. Add. Same cells must be greater than or equal to 1. Add. And then the same cell references must all have different values. Click OK. All right, it's a lot of work, but I think we have done it. So I'll click Solve and come back when Solver has hopefully found a solution. Great, it looks like Solver has found the solution. I'll click OK, and there we have our route, or routes rather. So we have 2 of them. They're both starting at the same point, and 17, rather than ending at 16 as this last point, it starts at 16, so that's equivalent because the distance is 0, and we have a total of 179, and those are some very good looking curves. So I think that our solution is probably at least close to optimal. I've already created solutions for 3 drivers with 1 empty spot and with 2 empty spots. So let's take a look at those quickly. I'll go to the 3 with 1 empty spot worksheet. And if I go down to the solution, you'll see that I made 15, station 15 here, the starting point. So there are 14 that they have to go to. However, because this value never changes, I was able to repeat it. So I could have done 16, or in this case, I could just add 15. So we're assuming that they start from the same point and go out, and there are the paths for the 3 drivers. All of the distances are calculated based on this cell and this cell, for example. So we're doing the distance from 15 to 2, which is 16. And actually, we can just barely see that that is, in fact, the value. So the lookups are working correctly. And the total is 208. And, of course, the map is displayed here. We can also see how to solve it with 3 drivers and 2 empty spots. So here, I have 14 and 15 with exactly the same coordinates, so they are effectively the same station. And here, we start from 15. And then we have 1 to 15 varying. So what we have are 15 and 14 being exactly the same spot. So we go from 15 to 15, which we can do because this value never changes. And it doesn't have to be distinct from the values in yellow. So we have 2 stations. So 1 through 13 are the only ones that are actually being delivered to. And the other distances, which are here, are 0. The other 13 have the actual distances from our lookup chart. So I encourage you to look through all of these solutions and see how that would work for you, and also how you could extend the solution even further to 4, 5, or more drivers. I hope you enjoyed this video. I understand that there was a lot going on, but if you got a lot out of it, and I hope you did, please like the video and subscribe to my channel.